So we have a question here that according to VSEPR theory, the geometries of FClO and F5IO respectively are. So we are given two compounds FClO and F5IO, and it is asked that what is their geometries. Okay, so for this question we will apply the VSEPR theory. Now first of all, considering FClO. Now we have to identify which is our central atom in this compound. So we know from the VSEPR theory that the central atom is the least electronegative one. So here among fluorine, chlorine and oxygen, if we compare the electronegativities, so Cl is the least electronegative amongst the three elements. So we consider Cl as our central atom. Okay, then the number of electrons, the number of valence electrons. So the number of valence electrons in Cl is 7. We know that the halogens have the valence electronic configuration as Ns2, Np5. So we have number of valence electrons equal to 7. So we wrote the valence electrons of central atom chlorine. Then how many electrons are contributed from fluorine and oxygen? So 1 each we will consider. But before that, we also should take care that when oxygen is involved, there could be a double bond. So VSEPR does not consider the double bonds. It is based only on the sigma bonded atoms. So that is why we will not consider the contribution that is coming from oxygen atoms. So the number of electrons gained from the bonded atoms, fluorine and oxygen. So we will consider only one electron is gained from these two, because we are not considered the contribution from the oxygen atom because of the doubly bonded nature of oxygen. Okay, so we add up these two, number of valence electrons of Cl, chlorine, and the number of electrons which are gained from the bonded atoms, fluorine. So 7 plus 1 is equal to 8. Okay, and then we divide it by 2 to understand the total number of electron pairs. So the total number of electron pairs are 4. If you just recall the VSEPR theory, I am following those steps only. When we apply VSEPR theory, we first consider the central atom, then the valence electrons on the central atom, then whatever is bonded to the central atom, and the electrons that are being contributed from the bonded atoms. And then we calculate the total number of electron pairs by dividing the total number of electrons divided by the factor of 2. So we have here total number of electron pairs as 4. Okay. Now how many bond pairs we have? So these are all the steps which are involved in VSEPR theory. So you can just recall and understand the steps. Okay, so coming back, number of bond pairs. So how many bond pairs we have? There are two atoms which are connected to the central atom. So we have bond pairs equal to 2. So that means how many lone pairs? So lone pairs is equal to total number of electron pairs, which is 4, minus bond pairs, which is 2. So 4 minus 2 is equal to 2 lone pairs. Okay. Now from VSEPR theory, we know here that when we have the total number of electron pairs is equal to 4, that corresponds to a hybridization of sp3. Why sp3? Because 1 s orbital and 3 p orbital. So 3 plus 1 is equal to 4. 4 orbitals are involved, and that is the total number of electron pairs, which corresponds to a hybridization of sp3. And what is the geometry of sp3? sp3 is tetrahedral. So here we get the parent geometry according to the number of electron pairs which contributes to a particular hybridization, sp3 in this case, which corresponds to the typical tetrahedral parent geometry. So that is being asked in this question. So what is the geometry of this particular compound? So we have tetrahedral geometry for this. Okay. And we follow the VSEPR theory. It is already given according to VSEPR theory. And then I hope this explanation is clear and the steps are clear. And then again we apply the same principles to the next compound, that is F5IO. But before we move to the next compound, we should also remember that when in the regular geometry, there are two lone pairs, right? So we have sp3 hybridization with tetrahedral geometry, regular geometry. But if there are two lone pairs involved in the regular geometry, then the regular geometry gets distorted. That we already know from VSEPR theory, that it gets distorted and it can be a bent structure and bent or angular structure, and it is not a pure tetrahedral geometry actually for this compound. So we can imagine like FClO, so how it should be arranged. So Cl is the central atom, and then there is a doubly bonded oxygen, and then we have fluorine. Okay, and then there could be the two lone pairs. So tetrahedral geometry is like this. Okay, so 3 here and 1 on top. So AB like this, AB4. So similarly, there could be these two lone pairs also somewhere here arranged like this. But since the geometry gets distorted, so this is a kind of bent or angular structure like this, the actual structure of the compound. But we will consider it as a parent geometry as tetrahedral only. Okay, now let's move on to the next compound, F5IO. Now in this compound F5IO, what happens? What should be the central atom? The least electronegative element. So obviously iodine should be the central atom based on the electronegativities of these elements. Now the valence electrons for iodine, so it's halogen, so valence electrons should be 7, like we did for the chlorine part in the first part of this same question. Now the number of electrons which are contributed by the connected atoms, so we have 5 F atoms and 1 oxygen. So again we do not consider oxygen due to its doubly bonded nature, and we will add up only the 5 fluorine atoms. Then we calculate from this data the total number of electron pairs. So how many? 7 plus 5 is equal to 12, and that has to be divided by 2 for electron pairs. So we have 6 total electron pairs. So how many bond pairs? So number of bond pairs here are 5 and 1, so 2. 5 fluorine atoms and 1 oxygen atoms are connected, so number of bond pairs should be 6. That is why the number of lone pairs is 6 minus 6 is equal to 0. Total number of electron pairs minus the bond pairs, so 6 minus 6 is equal to 0. So we do not have any lone pairs in this compound. Okay. Now, what should be the geometry? Total number of electron pairs is 6, and 6 total number of electron pairs contributes to sp3d2 hybridization, and which corresponds to octahedral regular geometry. Okay, so this should be octahedral geometry. This compound should have octahedral regular geometry, and since there is no lone pairs involved here, there are no lone pairs, that is why the geometry, the regular geometry is the actual geometry of this compound. So roughly we can say that if we take iodine as the central atom, then the something like this could be the possibility, the regular octahedral structure. So we have 5 fluorine here like this, and then we have a doubly bonded oxygen. So this should be the structure of F5IO. Now going back to the question. So what should be the correct option? So first one we have tetrahedral and the second one we have octahedral. So option 2 is the correct answer. So I hope this explanation is clear for this particular question. This is a question which has been asked in a competitive examination, and this is useful for all the students preparing for any kind of competitive examination where chemical sciences is one of the subjects. So I hope it is helpful, and thank you so much.